Welcome to The Explainer. Today, we're going to tackle one of the most crucial and, let's be honest, often tricky chapters for JEE physics, oscillations. We're here to give you a clear, actionable guide to absolutely master it.
Look, if you're gearing up for the JEE mains, these questions about oscillations have definitely been on your mind. And hey, don't worry, you are not alone in this.
So today, we're not just going to study oscillations. We're going to build a strategic battle plan, a roadmap for you to totally conquer this topic.
All right, let's dive right in. Every good battle plan starts with, surveying the battlefield. So first up, let's get a real handle on what we're up against with this whole oscillations chapter. The oscillations chapter usually gives you 1 to 2 questions. Now that might not sound like a lot, but think about it. That's a crucial 3 to 8 marks in your exam. That can literally make or break your rank, so getting this stuff right is absolutely key. Okay, this slide right here, this is your strategic guide. Just look at where the high weightage is. Simple harmonic motion, spring mass systems, and pendulums. These are your heavy hitters, your top priorities. This is where you need to focus your energy. Damped and forced oscillations, yeah, they're important, but you can see they show up less often, so you can plan your time a lot smarter. Okay, so now that we know what to study, the big question is how. A great plan is useless without the right tools. So what do you actually need in your toolkit to master oscillation? The classic question. NCRT, or should I jump straight to a reference book? Well, the strategy is super clear on this one. You have to start with NCRT. That's your foundation. Seriously, JEE Main loves to pull direct conceptual questions from it. Then, and only after you've got that down, you move on to a book like H.C. Verma. That's where you build the real muscle for problem solving and get that deeper intuition. So the big takeaway here is this 2-step approach. It's not one or the other. You use them together. Build that solid base first, and then you go in and sharpen those problem-solving skills. It's a system that works. All right, these formulas, think of them as your core weapons. Seriously, mastering these is non-negotiable. They're the language of oscillations. But, and this is important, don't just blindly memorize them. You got to understand how they all connect. Take a look at the acceleration formula. A equals negative omega squared x. What's that really telling you? It's saying acceleration is directly proportional to the negative of displacement. That's not just some random formula. That is the mathematical definition of SHM. Everything else, literally everything, flows from that one simple idea. Okay, we've got our toolkit ready to go, so let's talk execution. How do you actually put all this into practice over, say, the next month? And here it is, a clear, structured plan, broken down week by week. It's all about progression. You start with the fundamentals, right? Then you level up to the trickier problems. And finally, you get into exam mode, hitting those past papers and mock tests. This isn't just about learning. It's about building skill and, just as importantly, building confidence. Okay, knowing the material is one thing, but what about not losing marks to silly mistakes? That's a whole other ballgame. So let's pull back the curtain on the common traps that JEE setters love to lay in oscillations questions. First up, this is a classic, confusing SHM with uniform circular motion. They seem kind of similar, right? But they are fundamentally different, and mixing them up will absolutely wreck you on problems about phase. We're talking easy marks just thrown away. So here's the solution, and it's all about visualization. Just remember this, SHM is the projection of UCM onto a diameter. So picture a particle going around in a circle at a steady speed. Now imagine a flashlight shining on it from the side. The shadow it casts on the wall, that shadow moving back and forth, that is doing SHM. Once you get that picture in your head, the relationship becomes crystal clear. All right, trap number 2, getting the phase differences all wrong. This happens all the time. Forgetting the relationship between displacement, velocity, and acceleration is a super common mistake, and it's a goldmine for examiners setting up graphical or multiple choice questions. You absolutely have to commit this to memory. But here's a way to think about it. Picture a pendulum. When it's at its highest point, what's happening? Its displacement is maxed out, but it stops for a split second, so its velocity is 0. Now, when it's at the very bottom of its swing, displacement is 0, but it's moving at its fastest. See? That constant 90-degree phase lead is always there. It's a fundamental part of the motion. Okay, our third trap is a sneaky one. It's subtle and it catches so many students off guard. People just apply that simple pendulum formula without thinking, forgetting that it comes with a really, really important condition.
And here's the solution. That famous formula T equals 2 pi square root of L over G is only valid for small angles. We're talking like less than 10 degrees. If the question mentions a large angle of swing, you have to know that the standard formula is just an approximation. The real time period will actually be a little bit longer. And that little detail, that can be the difference between getting the question right or wrong.
All right, finally, let's talk about game day. How do you perform when the pressure is on during the actual exam? Look, knowing the content is half the battle. Having a rock-solid strategy for tackling the paper is the other crucial half. Having a clear sequence like this is an absolute game changer. You start with the low-hanging fruit, the direct formula questions. Those are quick marks. Then you move on. This whole process stops you from getting stuck on one hard question and wasting precious time. You grab the easy points first, build that momentum, build that confidence, and then you go back for the tougher ones. And these little things, these are the habits that save you from those painful, careless errors. Simple stuff, right? Like double-checking your units, is it centimeters or meters? Or just taking a second to ask yourself, does this answer even make physical sense? These habits can literally save your score. Make them part of your DNA when you solve problems. So there you have it. The roadmap is laid out. You've got the strategy, you've got the tools, and you know the traps to avoid. We've shown you what's important, what to focus on, and a step-by-step plan to get it done. The map is in your hands now. So what's going to be the first step in your battle plan? Are you going to dive into NCERT right now? Or maybe start by making that formula sheet? The next move is yours. Decide, get started, and go crush that exam.